ever ordered something online and wondered, hey, what if someone could just like tweak this URL and see someone else's order?
I see where you're going with this.
Well, today's deep dive takes us into that world web security, specifically vulnerabilities like IDORs and XSS. You sent us some really interesting sources on this. And
yeah, it seems like you're ready to move beyond kind of the basic definitions.
Absolutely. It's like we know the what, but now we want to understand the how, you know?
I'm with you. And that's where things get really interesting.
Right. So let's dive in. What exactly are these vulnerabilities? Like, let's say someone wanted to exploit them. What would that look like in the real world?
Okay, so picture this. You have this online shop. They think their system is super secure. Every customer gets a unique ID. So on the surface...
This is pretty solid.
Exactly. Unique IDs. Hard to mess with, right? Well, the problem wasn't the IDs themselves. It was how they were generated.
Go on.
They were sequential, predictable. And someone figured that out. They realized, oh, I can manipulate the ID in the URL. And boom, they're accessing other users' accounts.
Orders, personal info.
The whole 9 yards.
Ouch. That's scary. So even something as seemingly basic as like predictable IDs
can be a huge vulnerability. And that's an IDOR in a nutshell. Insecure direct object reference. It's like having all your apartment mailboxes, right? And the keys are just like in order.
Someone figures out the pattern, suddenly they have access to everything.
Exactly. You've also highlighted content discovery in web security, which is a whole other beast.
It does sound kind of like a digital treasure hunt.
Right. Think of it as the recon phase for hackers. They're using these techniques to find like those hidden directories, files, maybe even like exposed admin portals.
Okay, so they're looking for a way in, but how do they even find this stuff?
So there are a few approaches. Manual discovery is exactly what it sounds like. It's very meticulous. They're testing common file names, directory names. It takes time, but...
slow and steady wins the race.
Sometimes. Then we've got automated tools, these crawl websites. They're looking for specific patterns or anything that just seems off.
So it's faster, but maybe less precise?
You could say that.
Yeah.
And then there's OSINT, open source intelligence.
That sounds way more intense.
It can be. This involves collecting info from publicly available sources. We're talking social media, public records, even like website code repositories.
You'd be surprised what people put out there.
You have no idea. But let's circle back to those IDORs for a sec. We've got some notes here about encoded and hashed IDs.
Right, that sounds more complex.
It is. Think of encoding like a secret code, right? It scrambles the ID, makes it look like gibberish. Base64 encoding is a common one, but with the right key, you can decode it.
So it's reversible, like a secret decoder ring.
Exactly.
Yeah.
Hashing, though, different story. One-way street. You take the ID, put it through this algorithm, and you get this unique fingerprint. It's not meant to be reversed.
How do you even find an IDOR if the IDs are hashed?
Well, that's where it gets really tricky. Ethical hackers might create multiple accounts just to observe how the IDs change. They're looking for patterns, inconsistencies.
So even with hashing, it's not foolproof.
Nothing is. There are also websites like crackstation.net. They have these massive databases of pre-computed hashes.
So if you know the algorithm, you might get lucky.
You might. Now, you've also flagged this a practical IDOR example source. And this one is pretty cool.
What makes it so interesting?
It's like a hands-on demonstration. They give you a website, and you have to actually try to find and exploit the vulnerability. It's about understanding how the website works.
I see here they even give specific user IDs, like 1 and 3.
Exactly. And then they highlight this API endpoint, API v1/customer.id user ID. This is key because it shows you exactly where the website fetches user data.
And that's where the vulnerability could be.
Potentially. It's all about connecting the dots. And that's what ethical hacking is all about, right? Understanding the systems and finding those little cracks, but doing it ethically.
Right. So you can fix them before someone with bad intentions does.
Mm-hmm.
Now, speaking of bending the rules.
You want to talk about XSS, cross-site scripting.
It sounds like a whole different beast.
You could say that.
No.
If IDOR is like sneaking into mailboxes, XSS is more like slipping a note into someone else's mailbox that could impact anyone who opens it.
Okay, now I'm intrigued. What kind of note are we talking about here?
Imagine injecting a bit of JavaScript code into a website. Code that when another user's browser runs it.
Yeah.
Well, it could steal their cookies, log their keystrokes.
Hold on. Cookies. Like the things my browser uses to remember my logins.
Yep, those cookies. And XSS can potentially steal those. But let's unpack XSS a bit further. We've got a few different flavors, each with its own personality, you could say. Reflected, stored, and DOM-based.
Okay, break it down for me. What makes each type unique?
Reflected XSS. That's like a quick in and out job. Attacker sends a malicious link. You click it. Your browser makes a request to the vulnerable site, and bam, that malicious code embedded in the link, it executes.
And that code can do all sorts of nasty things, I imagine.
Oh, absolutely. Now imagine that code is permanently in the website. That's stored XSS, comment sections, user profiles, anywhere users can enter data.
So it's just waiting there for someone to trigger it.
Like a digital landmine. Then there's DOM-based XSS. It's more technical, but basically it exploits how the website's code interacts with the document object model, the DOM.
DOM. That rings a bell. So this type of XSS messes with how the website is put together.
Exactly. By injecting code that messes with the DOM, attackers can change what users see, redirect them to other sites, even create fake login forms.
Wow, that's seriously sneaky. Last time, we dove into the world of IDORs and XSS. Those vulnerabilities are scary. I'm ready for the other vulnerabilities you mentioned, like SQL injection and command injection.
Definitely can be more intense. With IDORs and XSS, those exploit weaknesses in how websites, handle data and user input. But SQL injection, command injection, those target the systems and servers, the underlying stuff.
So we're getting into the really dangerous stuff now. Let's start with SQL injection. It has something to do with databases.
Exactly. Databases, think of those as the brains behind a lot of websites, right? Storing all that user data, product info.
It's everything.
Yeah. And SQL injection, it targets the language these databases use. SQL.
So if a hacker can mess with those SQL commands,
they can get to sensitive data or even control the entire database. Let's say there's this website with a simple login form. Yep. You enter your info, the site checks it against the database, standard stuff.
Okay, so what could go wrong there?
Well, imagine instead of a username, an attacker puts in a specially crafted SQL query right in that username field.
A query, like how you ask the database a question.
Exactly. But this query, not so innocent. It could be like, show me every username and password in here. Or even worse, delete everything.
Wait, the database would just not obey that blindly.
If the website's vulnerable and doesn't check the inputs properly, then yeah, the attacker bypasses everything and is talking directly to the database.
That is a lot of power to give a hacker. It's not just seeing passwords, it's controlling everything.
You got it. And it's more common than you'd think, especially on older sites, ones that haven't been updated. Okay, enough about SQL injection. On to command injection.
Which you said is like giving a hacker, what was it?
Yeah.
The keys to the server room.
Good way to put it. Command injection lets attackers run system commands directly on the server with the same access as the website itself.
System commands? Like, what are we talking about here?
Think of the stuff you type into a terminal. Listing files, making new ones, running programs. You're interacting with the server's operating system.
Oh, okay. Okay, so if an attacker can inject those commands...
They could take over the whole server, upload bad stuff, steal data, even install a backdoor to keep coming back.
Hold on. So any website that lets users input data, if it's not protected, it could be vulnerable.
You're getting it. Say there's this website, right? Lets you ping a server to check if it's online. Normal feature. You enter the address. Site runs a command.
Yeah, seems harmless enough. What's the catch?
An attacker. They don't enter a real address. They inject a command. Something like... well, I won't say out loud.
You're kidding, right? That's all it takes. A few characters.
It's all about input validation. If the website doesn't check what's being entered, a massive vulnerability.
You officially made me paranoid about every website I visit. Okay, let's move on before I have a panic attack. What about path traversal? That one sounds like it involves dot exploration.
It does. Path traversal, also called directory traversal, it's all about tricking a website into accessing files that should be off limits.
So it's like finding the secret passageways in a video game, the ones that lead to, like, cheat codes.
Exactly. It usually exploits how a website builds those file paths, those ... sequences you see in URLs.
They take you back a directory, right?
Right. Now, say a website shows user profiles like this, /profile/John Smith. An attacker might try /profile /... etc. /password.
They're going multiple directories. What's in that password file?
On many systems. Sensitive user info, usernames, password hashes. If the website's vulnerable, boom, they can read it.
Okay, so path traversal is a digital treasure hunt, but the treasure is all our personal data.
And the consequences of finding that treasure, big. It shows how important secure coding is, checking those inputs, really understanding how file systems work. Okay, we've covered SQL injection, command injection, path traversal, all pretty scary. What about SSRF?
SSRF, server-side request forgery. I remember correctly.
Yeah, that's the one. A bit complex. But think of it like this. You're turning the server into a puppet. You're the attacker, pulling the strings, and the server. It's making requests on your behalf, even to places it shouldn't be able to go.
Okay, so SSRF. Tricking a server into doing your dirty work, even accessing stuff it shouldn't. It's like hacking with a middleman.
Yeah, like a proxy.
Okay, I like that. So how does that actually work?
So imagine a website, right? It has this feature, lets you preview content from other sites, like grabbing a thumbnail image.
Okay, yeah, I see now.
The server grabs that image from the URL you give it. Pretty standard stuff.
Right. So where does the vulnerability come in?
What if instead of a harmless image, an attacker uses a URL pointing to say a sensitive internal server?
A server that's not supposed to be accessible from the outside.
Exactly. Hidden behind firewalls, all that.
And they're using the website's server to bypass all that.
Exactly. The request is coming from a trusted source, so it might just slip right past those security measures.
And the attacker could get their hands on, well, who knows what.
Sensitive data, internal services. The possibilities are kind of endless, unfortunately.
This is all starting to feel very cat and mouse.
It is. And the rules keep changing. Which leads to a big question. How do ethical hackers even find these vulnerabilities? It's like trying to find a needle in a haystack of code.
Right. I mean, everyone says sanitize your inputs, but like, how do you even know what to sanitize if you don't know where the vulnerabilities are in the first place?
It's a lot of things. Tools, techniques, intuition. Automated scanners are a good start, though. Things like Burp Suite, OSBZB.
What do those do?
Think of them like those robot vacuums, right? But instead of dirt, they're looking for security flaws.
I like that analogy.
They crawl through a website, send requests, analyze the responses. They can flag potential issues based on what they know, but they're not perfect. Sometimes you need a human eye.
The ethical hacker.
Right. They go beyond the automated stuff, dig into the code, the logic, try to really understand how it all works and how an attacker might be able to exploit it.
So it's not enough to just find the vulnerabilities. You have to think like an attacker.
Exactly. You have to put yourself in their shoes.
It's like that saying, what is it? It takes a thief to catch a thief.
Something like that. And when they find a vulnerability, they don't just report it. They try to exploit it. In a controlled way, of course.
So they can see how bad it could really be.
And figure out how to fix it. Take SQL injection, for example. They might try different queries just to see what they can get their hands on.
So it's like a controlled demolition almost.
You could say that. And it's the same with those other vulnerabilities. With command injection, they might run some harmless commands first, just to test it out, then they'll escalate things, see how far they can push it.
All to make the internet a safer place.
That's the goal. And it's a never-ending battle, honestly. New technologies pop up, websites get more complex, and the vulnerabilities change too.
Well, you've definitely opened my eyes today. I feel like I've learned a lot. And I kind of want to go scrub my online accounts now.
It's a wild world out there. But hey, at least you're more aware of it. That's the first step.
Right. Knowledge is power. Or at least it makes you a little less powerless.
Exactly. Stay curious, stay informed, and never, ever underestimate cybersecurity. It's kind of a big deal these days.
Words to live by. This has been a fascinating deep dive. Thank you for joining me.
Anytime. Happy to be here.
And to all our listeners, thanks for tuning in. Until next time, stay safe out there.